let's take a look at normal distributions. Normal distribution can be denoted as x and mean and variance. Alright? So this is mean, this is variance. And if mean is equal to 0, variance is equal to 1, then x is equal to standard normal distributions. So how do we convert normal distributions to standard normal distributions? We can convert it through a formula, which is this. Z is a standard score, or we call it Z score. Z score is equal to x is a normal random variables, alright? Minus mean of the normal distributions over the standard deviations of a normal distributions. When reading a standard normal distribution table, there's few things for us to take note, alright? The first one, if let's say the question gives us Pz is equals bigger than A, what does this mean? Alright? It is referring to the shaded region after A. Alright? After A, all the shaded region. Alright? If let's say the question gives us Pz is smaller than negative A, meaning they are referring to the shaded region smaller than negative A. Alright? So, and take note that these two are the same. Alright? Provided A is equal to A. Alright? So the area here and the area here are the same. So what if the question gives us Z is bigger than 0? Alright? Meaning the 0 is at the fz axis, bigger than 0 is here. These are the shaded region. And what if the question gives us Pz smaller than 0? These are the shaded region that the question is referring to. Alright? And these two are equal. And also Pz bigger than 0 equals to Pz smaller than 0. Both of them are equal to 0.5. Meaning P negative infinity Z infinity is equal to 1. Meaning the shaded region area of this whole normal distribution is equal to 1. Okay, let's take a look at these questions. Given by the questions, the mean is equal to 8, standard deviation is equal to 2, x equals to 13, and we are asked to find the Z score, right? So for the normal distribution, this normal distribution can be denoted as x and it's not equal x and mean and variance. Variance is standard deviation squared, right? So this will be 2 squared. Alright? Then we convert it into standard normal distribution since we are asked to find the Z score. Alright? So this will be Z equals to x minus mean over standard deviations. Given by the questions, x is 13, mean is 8, over standard deviation is 2. Right? How much we can get here? 13 minus 8 divided by 2. We get 2.5. Alright? The Z score for this question is 2.5. Right? Next, let us look at another questions. Given by the questions, mean is 60 kg. Right? Standard deviation is 15 kg. Two part of questions. First part, we are asked to find the Z score when x is equal to 65 kg. Alright? So, first we write out the normal distribution denoted can be denoted as x and standard deviation is 60. So mean is 60. Then after that variance is 15 squared. Right? Then this is a standard normal distribution questions. So we convert it into this. Z is equal to x minus mean over standard deviations. Right? First part of the questions. We have to find the z score given x is equal to 65. So z is equal to x is 65 minus mean is 60 over here divided by standard deviation is 15. How much you get here? 65 minus 60 divided by 15 is 1 over 3. Alright, the z score for the first part of the question is 1 over 3. Then, second part of the questions, find x when the z score is negative 1 over 2. Right? So, z is negative 1 over 2. X, we don't know, we are asked to find. X minus mean is 60. Standard deviation is 15. Alright? Cross multiply. Here we get negative 15 equals to 2x minus 120. Right? 2 multiply x, 2x. 2 multiply negative 60 becomes negative 120. 15 multiply negative 1, we get negative 15. Alright? So 2x is equal to minus 15. Here moving to here become plus 120. So x equals to minus 15 plus 120 divided by 2. So x is how much? Minus 15 plus 120 divided by 2. We get 52.5 kg. Okay, now let's take a look at these questions. A factory produces metal spheres whose diameters are normally distributed with a mean of 10 mm and a standard deviations of 0.1 mm. Okay, first part of the questions. If a metal sphere is chosen at random, find the probability that its diameter is less than 9.85 mm. Given by questions, mean is 10 mm, standard deviation is 0.1 mm, and we are asked to find the diameter of metal sphere that is less than 9.85 mm. Alright? So x is the diameter of metal spheres. Alright? The normal distribution can be denoted as x and standard deviation is 10. Variance is 0.1 squared. Alright? Then now we are asked to find P, Z, P, x less than 9.85. And this is also equals to P, Z less than x minus mean over standard deviations. So this you get P Z less than x is 9.85, standard deviation is 10 over, yes, this is mean is 10, standard deviation is 0.1. So how much is here? 9.85 minus 10 divided by 0.1, which is that is less than 1.5. Alright? So refer to the standard normal distribution table, we will get 0.0668. Alright? This will be 0.0668. So the probability of getting diameter less than 9.85 to be 0.0668. Now let's look at the second part of the questions. If the factory produces 1000 metal spheres in a day, find the number of metal spheres that have diameters exceeding 10.15 mm. Second part of questions, we are asked to find the probability that is exceeding 10.15. Alright? So here we get PZ more than x is 10.15 minus mean is 10 over standard deviation is 0.1. So here is 10.15 minus 10 divided by 0.1. This is PZ more than 1.5. And according to the standard normal distribution table, we get 0.0668. Probability of getting diameter of sphere, metal sphere more than 10.15 is 0.668. So if let's say the factory produce 1000 metal sphere every day, so the probability of getting is 1000 multiply 0.0668, we get 66.8 metal sphere. Alright, so therefore there will be 67 metal sphere. There have more than 10.15 mm diameter. Alright, we cannot put 66.8 because we have to get a whole number for a metal sphere. Now let's take a look at the final part of the questions. Find the percentage of metal spheres that have diameters between 9.80 mm and 10.05 mm. Now let's take a look at the last part of questions. We are asked to find the probability to getting between 9.8 and 10.05. Right? Convert it into the standard normal distributions using this formula. We get 9.8 minus mean is 10, standard deviation is 0.1. Z, this is 10.05 minus 10 over 0.1. So how much we get here? 9.8 minus 10 divided by 0.1, we get negative 2. So here will be negative 2. Here will be 10.05 minus 10 divided by 0.1, we get 0.5. Right? So how do we find the probability of here? Let's take a look at this graph over here. So this is negative 2, this is 0.5. So we are asked to find the area over here now. However, according to the standard normal distribution table, they only give us the area over here for 0.5 and area over here for negative 2. So how do we find the area in between negative 2 and 0.5? We know that the total area of this normal distribution curve is 1. Alright? So 1 minus out the area over here, meaning after 0.5 here, and if we minus out negative 2 here, then we will get the area between negative 2 and 0.5. So 1 minus Q2 minus Q0.5. refer to the standard normal distribution table, we get 1 minus Q2 is 0.0228. 0.0228. Q 0.5 is 0.3085. 0.3085. Okay? 1 minus 0.0228 minus 0.3085. We get 0.6687. And convert into percentage, it is 0.6687 multiplied 100%, we get 66.87%. Meaning 66.87% to get a metal sphere that is in between the diameter have 9.8 and 10.05.